This problem is full of right angle triangles. Let's see if we can find all unknowns. We need to find A, B, C, and theta. To make things easy, we're going to represent C as the sum of C1 and C2. That way, we can calculate C1 and C2 separately and then add them up to get C. Welcome to today's video. In this video, we will be looking at this problem that I found, and we're going to see if we can find all unknowns. For ease of reference, I'm going to label these shapes as A, triangle B, and triangle C. So we're going to get started with triangle A. For triangle A, the unknowns we're trying to find are B and C1. To find B, we're going to invoke the trig ratio so, because we have the angle theta, we have the opposite to the angle 7 centimeters, and we need to find the hypotenuse B. Therefore, sine theta equals opposite over hypotenuse. Sine 44 degrees equals 7 centimeters divided by B, and B equals 7 centimeters divided by sine 44 degrees. If you punch that into our calculator, we'll get that B is 10.08 centimeters. We're going to go back to our board up here and fill it out. Next, we need to find C1. For that, we're going to write that tan theta equals opposite over adjacent. Therefore, tan 44 degrees equals 7 centimeters divided by C1. C1 equals 7 centimeters divided by tan 44 degrees. When we calculate that, we have that C1 is 7.25 centimeters. We're going to go back up here and fill it out. Great job. Now we're going to move to triangle B. For triangle B, all we need to find is our C2. Again, we have the angle 46 degrees, we have the hypotenuse 9 centimeters, and we need to find the adjacent, which is our C2. In this case, we're going to use CA. Cos theta equals adjacent over hypotenuse. Let's get to it. and write it out. Quite easily, we can now add it up to get C, which means that our C is 13.50 centimeters. We're making good progress, and now all we need to find is A and theta. Both of these unknowns are connected to triangle C, so let's get to it. First of all, there's something we need to notice. It's the fact that 44 degrees, 46 degrees, plus whatever this is, gives us 180 degrees. Remember that the sum of angles in a straight line is 180 degrees. If we do the math, we'll realize that this leaves us with 90 degrees. That tells us that triangle C is also a right angle triangle. In that case, we can easily find our A and theta. We're going to start with A. Remember that we have B as 10.08 centimeters, and we have this other side as 9 centimeters. Because of this, we can use Pythagoras theorem to find our A. How do we do this? Pythagoras theorem says that A squared equals B squared plus 9 centimeter squared. A squared would be 10.08 centimeters squared plus 9 centimeter squared. That is 101.6064 plus 81. Which is 182.6064 centimeter square. If we find the square root of both sides, we'll have that A is 13.51 centimeters. Now that we've found everything except theta, we can get right to that. To find out theta, we could use CA, which is using the adjacent and the hypotenuse A, which we just found. Or we could use TOA, using the opposite, which is B, and the adjacent that we were given. For the sake of this, we're going to use TOA. This is because A is a value that we've calculated from an already calculated value, B. So I don't want to use A. Instead, I'm going to use B, because for B, we calculated it from values that we were given. To find out theta, we will say tan theta equals opposite divided by adjacent. Tan theta equals B over 9 centimeters. tan theta equals 10.08 centimeters over 9 centimeters, which is 1.12. Therefore, theta would be the tan inverse of 1.12. That gives us theta as 48.24 degrees. Great job finding all the unknowns. I hope you enjoyed it as much as I did. If you enjoyed this video or found it helpful, please like it and subscribe to the channel for more math content.